Hello, Mr. right now, right? Okay, so let's look at this binary tree again, okay? 1, 2. What's binary trees?
A binary tree is a tree with numbers.
Where down? Okay.
The upside down tree.
Upside down tree. The root, the trunk, the leaves. Yeah, the leaves do not have any children. The root does not have any parents. If you look at upside down, this is the root. Yeah, this is the root. Okay, upside down. Yeah, this is the leaves. Okay. So the binary tree is a graph. Yeah. That does not have any cycles. Yeah. Directly acyclic graph. Yeah. DAG.
Cyclic.
Yeah. Does not have any cycles and it's connected one in one piece. Okay. If we have more trees, what do we call it? You know, if it is this is not connected, what do we call it?
Forest.
Forest. Yeah, exactly, forest.
Okay.
So yeah. So we only have one root, right? We only have one root. So for this one, you know, multiple roots. So multiple trees. Forest. Okay. So today questions very simple. So we want to find out the sum of the deepest leaves. Okay. Sum of deepest leaves. So how can we do this? What's the sum of the deepest leaves in this tree? Come on, 6 easy, exactly. Okay, how about I add another one? Okay. What's the sum of
16.
16 exactly. Okay. That's it. The question is very simple. How can we do it?
Easy.
How can we do it? Easy, yeah, it's easy. So how can we do it? How many ways we can traverse the binary tree and how do we do it? I mean, breadth search and depth search. Which one you think is easier in this case?
Depth search.
Depth search and how about you? Which one you think is easier? Both are okay. So which one you think is easier?
Depth search.
Depth search.
That's a wild guess.
Why guess?
I
And how?
think it's breakfast search.
Yes, breadth search, right? Because what?
It's a wild guess.
Why I guess? Okay, so breadth search, breadth search will travel the tree by level by level, and then we updated the sum. To do this in depth search, we have the dictionary, yeah?
Dictionary.
And the keys will be the levels, and the value will be the sum. So we traverse the depth search, right? We traverse the depth search, and then we accumulate the sum for each level, right? And then once we have this dictionary, so for example, this level, the sum dictionary, yeah, sum is the dictionary. Yeah? We traverse the binary tree, and then we pass down the levels, and we accumulate the sum for each level. And then what do we need to do? So we just need to return the maximum level, yeah, because it says the deepest, yeah. So it will be max s dot keys, and then that will be the sum. Okay, easy. So I think depth search is easier to implement for the breadth search, level by level. Yeah. Every time we take the nodes, because we know all the nodes in the queue. Remember, we talked about this a few days ago. Yeah. Look, if every time we put the first one, we put the root in, we take it out, we put the kids 2, 3 in. Yeah. We take it out, we put the kids 4, 5, 0. We take all the nodes out, push the kids 6, 10. So we always updated the sum. We keep a value of the sum for the current level. Yeah. When the breadth search terminates, then the sum will be the level of the deepest leaves. Okay. So let's go for the depth search. Okay. So we can traverse the depth search in the tree in how many order? I give you another example. Pre-order.
Stack.
Pre-order.
Stack attacker.
What do we have? Pre-order, in order, and what?
Post order.
Yeah. These are typically 3 orders. Yeah.
Typical.
Yeah, but maybe we can have this reverse in order. Yeah. In a binary search tree. Yeah? If we perform an in order on a binary search tree, we get this in order, right? We get the list in order. Okay. And let's say D equals the dictionary, default dictionary. Okay. Because we want to be able to use this default key, which is initialized to 0 if we given the value type is int. Okay. Define depth search, and then we have this first parameter as the root, the second parameter with the level. Okay. If not root, we just return. Otherwise, what? Look, D level plus equal root dot value. Okay. and then we just traverse the left tree, and then we traverse the right tree. And then what do? Return D max D dot keys. Okay. Okay, that's it. Look, I'm going to explain this, and then you need to tell me later. Okay. Come. Dictionary, default dictionary. Yeah?
Dictionary.com.
The keys will be the levels. The value will be the sum, and we just traverse the. Okay, so we have to call this depth search root, and then let's pass the parameter. First one is level 0. So we traverse recursively, and then when we visit this node, we accumulate the sum, the level with this root of value, and then we traverse the left tree, we traverse the right tree recursively, and then the sum of the deepest leaves, which is the max level, right? The max level. D dot keys is the level, max dot levels, right? And then we want to get the values. Okay? So the time complexity O(n), yeah? We have to traverse all the nodes. Each node is visited exactly once. The space complexity is O(n) or OH. H is the height of the tree, right? In the worst case, H will be the end, right? Okay, in the worst cases, OH equals O(n). Why is that? Can you tell me why in the worst cases, why the height is the number of the nodes? Can you give me an example, like in the worst cases, what does the binary tree look like? That the height.
Line.
Where lines look like line, yeah? Like that, yeah? Okay? Not exactly, not necessarily to be this a straight line, it could be like that, yeah? That's still OH equals O(n), alright?
Mm-hmm.
Yeah, makes sense? Can you explain to me what's this?
That's level and.
So we are adding, we are accumulating the sum for this level here, yeah? Okay, so there's another problem here. Level needs to plus 1, okay? I forgot this most important thing. Okay? Yeah? Because we're going down, we need to increment the level, am I right?
Yeah.
Okay. What have you learned today so far? Come on.
About
What have you learned today?
deepest leaves some.
What are we trying to do today? And what are we? What kind of algorithm can we use today?
We're using depth search.
Okay. And then what kind of? How do we implement this depth search? Recursion. And what kind of data structure we need to use to store the sum for each level?
Stack.
What data structure are we using? We're not using any stack
Dictionary.
here. Dictionary. To store the
.com.
keys and value, yeah?
Mm.
Okay, that's it for today. Bye bye.
Bye bye.
Bye bye.